Okay, very welcome everybody. First thing first, congratulations. You made it to the last session. One more time, it was my honor to spend another semester with you, and I hope everybody is gonna shine in the next step as well. Today, the plan is talking about cranking system, which is more focused on how your starter drive is gonna just ignite and how you are going to turn on the motor or engage the motor. But before that, I'm gonna quickly summarize the plan. I've already prepared 2 different quizzes for you. One of them is for the review. Definitely by the end of today, I'm gonna activate it for you, and you can, after you are done all the lectures, especially the one which I'm gonna post for you later today, which is about next lecture. You can watch it yourself, you can go through it, and of course, you need to complete the quiz for that one. So I've already prepared 1 quiz from charging, which was the plan and still is the plan to activate it for today. But before joining the class, in order to still you get another practice from the lecture, which is on Monday, and still be able to review that one, I'm gonna show you right in here. I have added some more questions to the end of it, which is going to be about that lecture. Therefore, we may have it today, or I can postpone it for Monday as well. So let's see how it goes. You can see it right in here, charging and cranking. Since cranking is what I'm gonna just finish it off, therefore it might not be easy for you to immediately take the quiz. I'm gonna give you a bit of more time. Charging is about whatever we've discussed on battery. If I just click it on right in here, you can see I have included this one. I only wanted to give you charging, but before coming, I decided to add more questions to give you another option to review what I'm gonna discuss today. Okay. So at the end, if you are comfortable taking both together, I'll activate it. If not, I don't mind postpone it. Then and I'll make it active for you online, and you can just go through it. Then you have enough option to practice both of them for your final exam. So let's see how it goes. Anyway, my quiz is ready. I'll activate it or not activate it based on how is your learning outcome. So let me share my screen and start conversation about cranking. Before I talk about cranking, is there anyone in here who can just quickly tell me what is the cranking system? Or generally, just the term or the keyword crank. What does it mean when we say cranking? What does it mean? Any idea? Cranking means turning the engine, right? When we say cranking, simply means turning the engine. If we are talking about the cranking system, means we are trying to understand how the engine is spinning or turning. So what you see right in here on my screen is the schematic of the cranking system in automotive application. Of course, cranking system needs power. That's why you can see I'm having the battery to be right in here. And that's another reason for teaching you the charging system before cranking system. Because cranking system is a combination of electrical and mechanical, but still we need power. Therefore, it has to receive the power through the battery. That's why you learned first about the battery, how battery is working, how generally charging system is working. And now it's time to learn about the starter. When I say cranking, now we are focused on the starter drive or the starter motor. And of course, everyone knows how we turn on the starter motor. Using your switch, right? The switch beside the wheel. So therefore, this is what we are going to talk about it. Inside the system, we have the battery, we have some magnetic switch, we do have some solenoid, which I'm going to introduce. And of course, these are like the starter motor and other components, which is going to be the topic of our discussion today. Everybody else just joining us, very welcome, kids. So let's start with the cranking. And what is the definition of the cranking? In fact, engine needs to rotate in order to generate torque. What would be the acceptable torque for the engine in order to turn on the vehicle? What would be the minimum torque that we need? We had this discussion before. 200 RPM, right? We need at least 200. So when I say cranking, I mean turning the engine crankshaft So cranking like action simply means we are going to turn on the starter and generate some torque in order to turn on the engine. So it is a device in here to rotate or to crank. So you can simply just instead of cranking, say rotate. So cranking is a rotating system. It has to rotate in order to generate some torque in order to start the motor. So in fact, this is inside the combustion engine, and it will start the engine operation under its own power, which is generated through the battery. So the purpose of the starting system is providing enough torque in order to just crank, or let's say increase the cranking speed. We start at 200. If you want to speed it up, which is happening through your gas pedal, we are spinning it faster. That's why we are generating higher torque. That's how it works. So starting or cranking is the, I would say, heart of electrical system in your vehicle. Without this part in your automotive, without this part, your electrical system doesn't do anything. Simply means none of the component inside your vehicle is gonna work. So this picture in here is different components inside the cranking system. I'm gonna quickly go through it, and of course, right after that, I'll show you a video which is showing how practically ignition is happening from the minute that you are pushing that start button in your vehicle, or if you have a switch, you are turning the switch, how solenoid, cranking system, battery, and all of these switches are engaged, in which order they are connected. For example, this is the exact same switch in here, which you have it inside your vehicle either as a button or as an physical switch. When you turn it, you can see this one is in a series connection with the battery. So it's in between the battery and the starter. Therefore, when you push this one, most of the vehicle nowadays, they are updated, and still we do have vehicles that they are physical switch, but if it's the push button, if you push it, means you are sending the current from the battery to the starter. Right in this circuit, you can see solenoid is in between. So solenoid is in between the switch and the battery. So of course, you do have another in here, another safety switch or the clutch switch, which you can see it right in here. This one open the starter. So first, this one will be engaged. It will open the starter through the solenoid, right? And then right after that, this switch is in fact normally connected to the transmission to apply the current from the battery to the motor, right? Therefore, I would say this is in like a standard transmission connected to your clutch. As soon as you push the clutch or you hold the clutch, means you are just engaging this switch, and that's how you can turn on your starter. And of course, in the situation that you are set to reverse, this switch, when you are setting your gear to the reverse, this switch is engaging the back lights. Therefore, it is turning on the same switch. It is turning on the back lights for you. And of course, as I said, in order to start the engine, you have to have at least 200 RPM. Keep this in mind. And of course, in here, see the solenoid and how is the connection in solenoid. And then I'll get you to look at the functionality with more detail. But pay attention. This part is what is actively acting like a relay connected to the solenoid. So this one, you can call it even a relay, which is connected to the solenoid. And then right in here, you're having a handle. What will happen? So after this relay is engaged, this handle in here will push the starter driver, which is this part, and through this gear, spinning this gear, you are gonna send the current, or let's say you are gonna pass the current to the motor. And that's how you can turn on your vehicle. Therefore, so see how many components are engaged in turning on your vehicle. You can in here also say, this is your starter, and this is your flywheel ring gear. And let me show you how they are working inside the vehicle. Try to learn the connection, the functionality, and how they work together. So
an engine starter motor is a powerful electric motor used for cranking an engine. The starter motor has a pinion, which meshes with the teeth on the flywheel of the engine and turns the crankshaft. The model shown here is a pre-engaged type starter motor used in modern vehicles.
Pay attention. In here,
the power for this motor can be drawn from the battery.
In here, you can see the connection. Look at here. This is the same ignition switch, which is in series connection between the battery and the solenoid. Therefore, this is your solenoid, right?
Simplified circuit of power supply is shown here. The power from the battery is supplied to a solenoid. An ignition switch is installed between the battery and the solenoid to turn the power on and off. The solenoid is an electromagnet which requires small current to get energized. As the ignition switch is turned on, the solenoid gets energized. A moving core known as a plunger slides along the coil, which connects two copper terminals of a contactor switch. This completes the circuit from the battery to the motor and causes the rotor to spin. When the solenoid is de-energized, the core returns back and disconnects.
Before learning more in here, in the upcoming slide, I'm going to show you in more detail, but have it in mind. Inside this solenoid, you do have two types of coil. We call them pulling and holding coil, right? Right in here, two types of coil. Right now, it is open. Before, if you remember, it was covered completely with coil. And one of this pulling and holding is the one, like pulling is drawing the energy from the battery, which is this part, right? And holding is connecting it to the starter, right? Therefore, when I say pulling and holding, I'm talking about the wiring or the coil on the same solenoid.
The motor from the battery. We may wonder why the solenoid and the contactor are used instead of directly connecting the battery to the motor and reducing the complexity. The reason behind not using this circuit is the high current demand of the motor. The motor is considerably powerful and demands heavy current for operation. To handle this current, the ignition switch needs to be unusually large. It also requires very thick wires running from the battery to the switch and then to the motor, which is technically inconvenient. This is why solenoid is used, which demands lower current for being energized. The solenoid has another crucial function. It helps to slide the pinion and engage it with a flywheel before the motor starts to spin. As the pinion slides towards the flywheel, it slightly rotates on its axis, as shown here. This rotation is achieved by using a helical spline. This rotation helps meshing the pinion with the flywheel more conveniently. As the pinion and flywheel is properly meshed, the contactor switch gets closed, and the motor spins. As we can observe that the pinion is considerably small compared to the flywheel, the gear ratio of the
Another thing in here, look at this gear. Therefore, the speed of this gear is what exactly impacts the speed of your vehicle. If it is spinning faster, you are driving like maybe with more speed. So this is super important. In an upcoming slide, I'll introduce it. But since now you see the picture, just keep it in mind when I say how much this one is important in your speed. This is because this one it is faster. This is which is connected to the motor, spin faster because of this guy. It can speed up your driving experience.
Flywheel and pinion is generally from 15:1 to 20:1. The high torque obtained from this gear reduction is still insufficient to crank the engine. So, a planetary gear set is introduced to increase the torque further. Planetary gears are incredibly useful for large gear reductions with less weight and limited space. It consists of a sun gear, a ring gear, a carrier, and a set of planet gears. In starters, the ring gear is fixed, the sun gear is the input, and the planet carrier is the output. For the setup shown here, the gear ratio is 7:1. The combined gear reduction results in enough torque to spin the engine. As the engine is started, the pinion needs to be disengaged from the flywheel to prevent backdrive of the motor, which might damage it due to the excessive speed. This is done by releasing the ignition switch, which de-energizes the solenoid and the pinion returns back. But if the operator fails to release the ignition switch as soon as the engine is started, the flywheel will drive the pinion too fast and damage the motor. To prevent this, a one-way clutch is used. The one-way clutch has a set of rollers installed between the outer and inner races. When the outer race is rotated by the motor, the rollers get trapped and transfer power to the pinion. As soon as the engine is started and drives the pinion at a high speed, the rollers get released and power transfer is stopped.
Okay, now keep this in mind, and we are going to continue understanding more about what's the role of the like having cranking system or cranking circuit in here. So this schematic in here is showing the transmission status in Toyota. This is like a schematic of Toyota cranking system. Looking at here, you can see you have a disc, or let's say you have like a position for the neutral position or switch position right in here. What will happen? For example, if I compare this part and this part, both of them are the same system, but sometimes it is open, sometimes it is closed. Means in the right side, right in here, transmission is not set to parking position. Look at here. I'm not sending anything to the parking or neutral. This is the parking, this is the neutral. Therefore, immediately it will go to ECU. So if the command is going to the ECU, means the motor is not started. No start for the motor, right? But how about here, left part? Left part, you can see that I am sending some signal or some command to the motor. How? By setting the parking position. So I set the parking position, right? When I change the gear to parking position, I'm connecting this part, which is the starter relay. I showed it in the previous slide, to be connected to the starter motor, right? So therefore, in here, transmission switch is checking the status of this parking, or it's like, let's say, this position switch. That's why in the previous one, I said we have a safety switch and we have a position switch. That position switch is either neutral or parking. Therefore, in here, the current is passing through the position switch to the starter motor. Make sense? That's how we can crank. So position switch is in fact acting like a mechanical. This is like a mechanical blocking switch. This is how this guy is doing. And this is going to stop the starting of the motor when the gear is not in the neutral position. If it's not in the neutral position, we are stopping the starter of the motor. Now let's look at the structure of this starter motor right in here. In fact, this one couldn't be now complicated for you to understand because I've already introduced the solenoid part of it, which is going to be here. Now look at the shoes. These pole shoes in automotive application, the motors that we have, mostly we do have 4 of them. In this picture, you can see we have 4 of them. And these shoes, this is 1, 2, 3, and another one right in here, 4 of them. They are supposed to hold the winding of the motor, and through those, which is like heavy copper, we are going to pass the current through the winding to the motor. This is how these guys are going to help us in order to turn on the motor. Now let's look at different type of a starter motor. As we have different type, we have series connection, we have parallel or shunt. Both of them are the same. Do not confuse. These two are not two different type. If you have it as a like theory question inside your exam, if I'm asking about the shunt or if I'm using the term parallel, both of them are the same. So in series motor, we have the coil or the field coil to be connected with armature in a series connection. If you can remember my conversation with like the charging system and the connection of the batteries, different type of the connection series parallel in there. Also, I'm not talking about the battery right in here, but generally series and parallel connection in any system simply means there should be a difference between keeping the current constant or keeping the voltage constant. That theory is the same theory right in here. When we are looking at series connection current is remaining constant between the component or voltage? Which one? We are going to have different current through each component or different voltage through each component. If I'm having, let's say, if this is my series connection, series field, which I'm going to connect it to the armature, suppose let me clean this up. Suppose I'm sending some currents. You have some interaction in here. If this is my current being connected to here, this is positive. Therefore, this is my ground. Then what will happen? If I'm going to draw it for you based on the basic of electromagnetic, which I'm pretty sure everyone knows it, and we had the review also before. If this is your field, right? We are talking about F equal to LIB. Remember? That's what we are looking at. Therefore, now if I'm going to draw the same armature right in here, something maybe like this. If I'm going to have that armature, so armature current is moving. This is my armature current moving in this direction. And suppose this is going to be my brush. Therefore, if this current is moving in this direction, in here also the same current, in this direction it's going to be like this. It's coming out like this. Now, if I'm looking at the F, if I'm going to calculate F, what should be F? If the direction of the field is like this, simply this is going to be my F, right? Right-hand rule. Can you remember right-hand rule? Suppose these are my wires. And then if this is I already have the I, then how should be, and this is my B, how should be, this is going to be my F, right? This is the same F. This is the direction of F. Remember, F is going to be top, and then the current, consider the current. If I'm going backward, then this is going to be F. Now, having that understanding, L is going to be the same, but if I is decreasing, and since my connection are series, B is supposed to decrease. Make sense? Therefore, in this situation, I'm going to have less torque at high RPM. High RPM means faster spinning. If it is spinning faster, I'm going to have less torque. Make sense, kids? I'm going to have less torque. So you can say, if this is the direction of I, I'm having back EMF to be in the opposite direction, which is I EMF. Since I is decreasing, then B is also decreasing. Therefore, I'm going to have less torque at high RPM. We have also another type, which is going to be, but if I'm going to summarize this one, if I have high RPM and I have high IEMF, then how should be my torque? So high IEMF, and then I'm having high RPM. You may want to have this one in your mind. Then I'm going to have less torque. This is the summary of what I have, right? And then I'm going to look at the shunt, or I would say parallel connection. Remember I said in here, current is going to stay equal, but voltage is going to change. Voltage is going to be, for example, V1, V2, and so on. But how about here? Here, my connection between the coil and the motor or the starter or armature, whatever you wanted to call it, is going to be series. Therefore, here, I is going to be I1 plus I2 plus whatever. And voltage or total voltage is going to be equal by whatever other voltages that I have inside the system. So with that understanding, now I'm going to rewrite the same equation. Again, I'm going to have F I L B. In this situation, what will happen? This is the parallel, in fact, connection between the field coil and armature, or I would say shunt. Then suppose I'm sending current. Let's look at how the current it is. Suppose I'm sending current from here. If this is my current, then this will be a splitted between the two components. One current in here, another current in here, right? So I'm going to call this one I1, I2. That's why in here I said I is I1 plus I2. Makes sense now? Then on the other hand, what do I have? Back EMF, right? How is the direction of back EMF? Always in opposite direction with the I. If I is in this direction, then I EMF is in the other direction, is opposite. Therefore, if I'm going to rewrite the equation based on this one now, if I reduce the current, what will happen to B, or the magnetic field? It should be opposite, right? Therefore, in here, if I reduce the current, not the length, if I reduce the current, I'm gonna increase the magnetic field. That means I'm generating more torque. If I'm gonna summarize again, like the other one, therefore I'm gonna say, in this situation, if I am reducing the current, simply means I'm going to also reduce actually the RPM, right? And then I'm going to increase the B. Increasing the B means, sorry, increasing the torque. How about the torque? Torque is gonna increase. B is also increasing. Current is reduced. B and T is gonna, at the same time, increase. Therefore, I'm gonna have decreased torque at higher RPM, right? At higher RPM, if I have RPM to be like decrease, then I'm gonna have otherwise torque is going to decrease, opposite to this situation. Make sense? In order to generate higher RPM means you have to increase current. That's why it becomes otherwise or opposite. Any questions so far? Is it clear? Therefore, it is important to understand functionality of each of these components in here. And of course, you are not going to have calculation from this part, but understanding it is super important. We have another type of motor in addition to the series and parallel or shunt, which is called compound. In fact, I always say compound is a combination of both series and parallel. What was the specification for those two? Compound in here is going to help with having a consistent torque at higher RPM. So I'm going to have consistent, or I would say better or improve or higher torque if I'm having higher RPM. Makes sense? So mostly companies like GM, Ford, Chrysler, these kind of companies, they are using such a compound motor in order to get advantage from both of them. In fact, shunt or parallel gives extremely efficient regulation for a speed, but series motor has a great, and I would say high starting torque, as I said in here. This one has high starting torque. This one, it will have high starting torque. And most of the automotive companies, they are using, this is more common, they are using series, but some of the companies, they are using the compound, which is a combination of those two. So series is more common in other application. If you are asking which one, series going to be like a bit more common in automotive application. In addition to that one, we do have permanent magnet motor, but this one is in fact working based on magnetic field. So they are going to generate magnetic field in order to start the motor, but there is some disadvantages. This one is really sensitive to vibration, and since motor while you are driving naturally is going through lots of vibration, definitely is going to cause a lot of damage for the motor. Therefore, I would say this is not the best option. Another advantage is over time, magnetic field will become weaker and weaker. And of course, based on the explanation in the previous slide, if you are having a weaker magnetic field, means you are generating less torque. And if you are generating less torque, there are situations that you are unable in order to generate that minimum torque for the start of the motor, which is going to be 200 RPM. Therefore, this is not the best option for automotive application, but still another type of the motor that you need to understand about it. And again, I repeat, series motor are going to be the best option, or I would say more common option for automotive application. Any questions so far? So I'm going to quickly go over a little bit more a step. Also, I already, I would say, explain all of this part. Remember, I said in a starter motor, we have different components. I'm going to introduce remaining component, which was not the part of the video on the previous slide, which is going to be reduction gear. I touched it before inside the video. I said later I'm going to talk about it. This reduction gear is the one which is building the connection between the starting part or the starter part and the motor. Therefore, if this guy is spinning faster, the motor is spinning faster, right? Therefore, this is super important to understand what's the application of the gear reduction starter. So it is a spinning faster. If it is a spinning faster, electric motor is going to be impacted accordingly. So it will reduce the speed of a higher speed electric motor in order to, I would say, extract the torque at flywheel because it is connected to the flywheel. Another one is the clutch in here, or we call it even overrunning clutch. This one, if it is a spinning faster, it will faster than the drive pinion. You saw this drive pinion inside even the video. Then it is going to impact the functionality of the flywheel. Flywheel is like right in here. In between this part, right in here, you have another component which we call it mesh spring. What is this mesh spring? This one is gonna just help in order to build the connection between the overturning or the overrunning clutch and the flywheel. This one is impacting between the overrunning clutch and the pinion, which is controlling the flywheel performance. This is like a disc. It's not gear anymore. This is just like a flat disc in there. Another thing in here is, again, functionality of the solenoid. Remember, I said later I'm going to talk about the pulling winding and holding winding. Those winding in this picture, you can see the pulling winding is this red. Sorry, the holding winding is this red, and the pulling winding is this green winding. What's the difference between them? In fact, in here, pulling is going to pulling in here is going to send the current to the starter. Holding is connected to the battery. So it is receiving the energy from the battery and it is sending it to the starter through the pulling winding. That's the difference between these two, right? Another important factor that I need you to understand about it is this disc right in here. I've got a disc which is exactly the component which is going to connect your solenoid to the starter motor. If I go to the previous picture, look at here, this is the solenoid, this is the starter motor. So there is a disc between these two. Now, in a different picture, if this disc is open or is closed, like this one in here, it will exactly engage the pulling and holding, which is again from the previous slide, these two wires. Right? So what does that mean? In this picture, you can see I'm having it closed. The disc is closed simply means the solenoid through the winding is connected to the starter motor. Therefore, I'm sending the current right into here. But if the disc is open, there is no connection between the solenoid and the starter motor, means you are not going to turn on the motor as well. So therefore, if I'm asking you what is the impact of the disc right in here, or we call it even contact disc, now you know that the contact disc is the component which is connecting the solenoid or disconnecting the solenoid and the starter motor. And definitely, if you are having, for example, your starter motor is not working and you are trying to troubleshoot what is the reason for the starter motor to be engaged, one of the important factors that maybe the maintenance guy for you is going to evaluate is having a healthy disc in here. Probably you have heard about this disc a lot. Sometimes it is weird. Sometimes it is like it's worn. It's like damaged. It is maybe the shape is changed. Therefore, if this one cannot build a constant, or I would say reliable contact with this two terminal, positive terminal and negative terminal, is not able to turn the starter, and you cannot turn on the vehicle. In order to wrap up, I'm going to quickly come up with some troubleshooting, because there are lots of issues that it may happen for the starter motor, and you may be able to figure out at least what is the issue. If you don't want how to fix them yourself, but at least you can understand what's going on. One of the issues is going to be if you have some wane, that might be like in order to just figure out what that wane is in there, it might be because of the starter drive being damaged or worn. So if it is so, if the starter motor is spinning, but it doesn't make the proper contact with the engaged flywheel, as I show you in the previous slide, simply means you are not going to make 200 RPM. And if you are unable to have the 200 RPM for the cranking, you cannot turn on the vehicle. Therefore, you have to go ahead and you have to check the mechanical part to just fix that situation. Another issue is if the starter fails to rotate, that simply means your ignition switch or the safety switch is faulty, right? Therefore, you have to look at the ignition switch or the safety switch. Another one could be if you are going to have a starter rotate slowly. That's a function of your battery. Either you are having a little bit of resistance somewhere between the battery and other components being created, causing you to lose a little bit of voltage, right? Therefore, you are going to have resistance either through the maybe longer wire or something which causing that resistance. You need to check that part. Or there are situations the actual battery is faulty. And if the actual battery is also faulty, therefore you are going to have a starter rotate slowly at some point if it is not completely damaged, or if it is completely damaged, it's not going to even rotate at all. Another issue might be you hear clicking noise. That one is because the battery is discharged. If you are hearing, when you are trying to start your vehicle and you are hearing some clicking noise, your battery doesn't have enough energy, therefore you have to look after that one. Voltage drop test is very similar to what we had in the previous slide. You always need multimeter to be connected to the battery and the starter, between the battery and the starter, and look at the procedure. You have to definitely remove the fuse or relay. Why is that? This will help you to review quickly the previous lecture. Because fuse or relay are the safety features or safety component, right? Therefore, if you are going to test the functionality of the battery and the starter, remove the fuse or relay, then look at their functionality through the multimeter. Another one is the starter amp test. Amp test, we do have like this device, which is going to be used in order to look at the starter motor. This part of it, this is the current sensor, right? You have to just put it around the cable and you can read the current through the device. Another one is going to be the maximum. This one has, in fact, I would say some standard. You have to just compare it with the standard. For example, in this slide, I have included all of the standard. If you are using 4-cylinder, you have to have the current to be between 150 to 185. This is not something that you can set it up. You have to look at the standard for that certain vehicle and compare it. If it is anything less than this, then you are going to have a faulty situation. If you have excessive current, it should be through the, maybe you have to look at the oil tank in case there is some issue in there. If again you have low amp, probably you are going to have some voltage to be drawn or to be wasted here and there. You have to look at all of the cables, all of the wire, check their functionality, check their like even their length, their insulation and everything, to make sure they do not have any wrong contact with other component which is causing you voltage drop. And lastly, it's going to be about the flywheel clearance. This one has some step-by-step I would say procedure that you need to consider, but the main part of it is being familiar with shim. Shim is a device, it's a flat device in order to measure, in fact, or let's say clear the starter in here. So you have to clear between the starter pinion and the engine flywheel. This is the flywheel. Look at here. This is the flywheel and this is the armature shaft. You have to put the device in between them and you have to measure it. There is again a standard. You have to use a 1/8-inch diameter drill bit. You have to just see if it is fit or not. And through that, you can have a proper clearance. If the gap between them is not the standard gap, you have to adjust it in order to have the a standard gap. And usually it causes even noise. If it is like wider, it causes even noise, or if it is not set properly. And the last one is going to be cleaning up some dirt from greasy starter. You have to take it off. You have to disconnect the brush and plate, and then you have to disconnect the ring gear, the pinion and everything, and then clean it up properly. And then for installation again, you have to first put new brush, and then after you put new brush in the system, then put it back in the system and assemble it. So this is all you need to learn about the cranking system. Still, we have few minutes. If you have any question, feel free to ask. This part is really important, especially because everybody has cranking system in their vehicle. Even if you are not going to learn experimentally how you do fix any of the troubles in your vehicle, at least with this understanding, you can understand, for example, what's the issue, and you can take it to the maintenance guys to fix it for you. So I'm done. If any question, let me know. Otherwise, I'm gonna just stop this one and talk about what we have left. Let me stop this recording.